Good day, and thank you for joining us as we explore Fluid Cooling Systems, LLC, a manufacturer in Flint, Michigan. My name is Jackson Ball. Many of you know me from years in the chiller business. Over the next 20 minutes or so, you're going to learn about Fluid Cooling Systems products. But moreover, you're going to learn about the compelling value that off-site manufactured, fully integrated, and engineered packages provide to owners, engineers, contractors, the whole family of stakeholders. Fluid Cooling Systems, or FCS, is an 11-year-old ISO 9001 certified design-build manufacturer based in Flint, Michigan. We manufacture integrated engineered packaged systems from small to large. We work in HVAC and in process. In the HVAC world, we're known for modular chiller and boiler plants, pumping stations of various types and sizes, heat recovery systems using plate heat exchangers and other devices, and we provide integrated optimized controls using either PLC or DDC algorithms. In the process world, which is where we really are well known, we build process cooling and heating systems, energy recovery and energy transfer. We can handle various types of industrial fluids, and we are known for meeting very stringent specifications. Complexity made simple. Fluid Cooling Systems has earned a valuable reputation as being design-build champions for our customers, primarily because of our diverse work in the process cooling world. We build many types of HVAC systems as well: chiller systems, pumping systems, cooling tower systems, heat recovery, heat rejection systems, among the few. Our work with data center is in two directions: in traditional data centers and in crypto. Crypto is a bit different because these are ASIC type of servers that sit in an immersion bath of a dielectric fluid, and fluid is moved at high velocity across the servers itself in order to do one thing and one thing right, and that's make bitcoins. We also work with power, gas, and electric, chemical and pharmaceutical, and there are many different types of applications in chemicals and pharmaceutical plants. Metals and plastics can involve die casting, extrusion, and injection molding. And we are approached by our customers often to provide custom solutions, things that have not been thought through thoroughly yet. We have a reputation for innovation in design. We do, in fact, provide solutions to our customers. Beyond the products that we manufacture, there is something even more compelling that we deliver to our customers, that being a resource for off-site manufacturing. There's a convergence taking place, and it's compelling. I think the best explanation is given by ASHRAE President Charles E. Gulledge III in a recent article in ASHRAE Journal. Quoting from him, quote, "Off-site is one of the strategies available to us to demonstrate competency of the holistic lean narrative," unquote. Quote, "When applied correctly, this equates to high quality, reduced overall project cost, and improved schedules," unquote. Quote, "Mastery of the off-site narrative is achieved when we become aware of our fragmented ways, understand how to alter our delivery models, realize how collaborative optimization can be structured, and demonstrate that we can provide better experiences for our clients," unquote. Thank you, Charles E. Gulledge, for the beautiful explanation of why off-site manufacturing is so compelling in today's marketplace. Off-site manufacturing creates owner value in four big areas: money, time, efficiency, and total cost of ownership. With respect to money, factory modules just cost less to build. Some estimate 25 to 30%, and this is common across the industry. There's also the aspect of the compressed time use of money while on a project. Risks and chargebacks revolving around the machinery that's being built off-site are obviously eliminated. Time and speed, parallel manufacturing assures more rapid projects. Commissioning and turnover are simplified. There is streamlined coordination enabled through off-site manufacturing. When it comes to product efficiency, engineering intent becomes reality. The pressures, temperatures, velocities, and flows are assured in an off-site manufactured system. Hydronic fundamentals are also assured. With total cost of ownership, modules perform better and saves operating costs. There's also a tax benefit worth exploration. Item amortization versus square feet. You could be able to amortize the entire piece of equipment as one. And it also enhances tenant and property valuations. There are examples in California, for example, where the building itself became more valuable just because of the modularization of the infrastructure. In a recent article, Goldman Sachs coined the phrase, resource density is very real. There's a convergence taking place, they saw. Of course, their emphasis was on money, but let's look at it when it comes to manufacturing. Certainly there's a convergence of cash, credit, and flow. There's a convergence taking place because skilled labor shortages are occurring throughout the country. A coordination and logistic points towards more coordination, more convergence. There's an aspect of controlled access where you want fewer people to have access to your critical equipment. There's a convergence of space usage. Can you get by with less space? Can you free up your equipment room by moving your infrastructure outdoors in a module? Having all of your products, all of your systems, your boilers, chillers, flow control valves, heat exchangers, and set points under one control system is a great advantage and points to another convergence. Maintainability. A modular system is easier to maintain, again pointing towards this convergence towards modular construction. Portability. A module can be moved to a new location for a plant expansion, for example, or reduction in plant size. We talked about the amortization. This is actually something that is a beautiful incentive to buy a modular chiller plant, because you're able to take the entire plant and amortize it as one single unit in a rapid way, as opposed to a long-term amortization per square feet in an equipment room. Build qualities become more and more important these days, and certainly the ability to guarantee build quality is more highly assured in a plant manufactured. Time, use of money. We've talked about that. It's all around the project speed. How many dollars and how long of a time do you need to allocate money on a project? There are job site risks from employees. Items disappear. There are injuries that can take place, and those risks are mitigated when you engage in off-site manufacturing. The asset value itself, not just of the equipment, but also of the building itself. There is evidence that a properly constructed infrastructure, modular especially, increases the asset value of the building. Hydronics. How often do we see pipe bends that should not be where they are, or see reductions that are too small for the flow rates and for the velocities and pressure drops? When you engage in off-site manufacturing, those risks are pretty much eliminated because everything is designed in. All the proper fluid flows, pressure drops, and velocities are assured. Biggest thing, do it once, do it right, and modularization is really the way to go for that. So yes, at Fluid Cooling Systems, we make great products and a diverse range of products. But if you really get down to it, the engineered products that we design and build are a vehicle to deliver the comprehensive solutions and lasting owner relationships and value that are really sought. It's more than about just the products. It's about a convergence taking place. It's about resource utilization and the density. And it's about lasting value. So the trend is towards packaging, and some very compelling reasons are driving that change. Certainly reduced project timeline is important, risk and money. You obtain higher quality, You obtain higher performance and higher overall total cost of ownership when you package. Fluid cooling systems is unique in the fact that we have expertise in process and HVAC, and we have a very, very high build quality that customers have come to appreciate. Our flagship product is the Modular Mechanical Room, or MMR. It can house chillers, boilers, pumps, heat exchangers, cooling towers, drives, and valves, all piped and wired under a single DDC or PLC control system, and we can use your preferred brands as indicated. Modular mechanical rooms are typically enclosed for outdoors, or they can be provided as skids. We have also provided them for rooftop installation. Disciplines are united under one roof in a controlled environment during off-site manufacturing. This is one of the big value creations that are available. The systems are engineered and built by professionals who do only this type of work along people they know well. There's a trust there. Quality, reliability, efficiency, and ultimate owner value start as a team on our factory floor and extend all the way to the customer. Modularization frees expensive interior mechanical room space, and modules cost less to build. Let's look at two sample projects for the MMR. One is at Ford Motor Company. This project involved 5,200 tons of chillers in 7 outdoor modules, all tied together of course, for process chilled and condenser water system. It is a design build project. It includes the UL Motor Control Center, controls, and instrumentation. On the chill water system, there were 4 centrifugal chillers totaling 5,200 tons, 3 pumps, 2 in operation, 1 in standby, 18-inch welded steel piping that was then insulated, and it included duplex basket strainers. On the condenser water side, there are 4-cell cooling tower systems, 3 pumps, 2 in operation, 1 in standby, and 24-inch welded steel piping. The condenser water system also includes Spyrex centrifugal separator for full flow filtration, and also a chemical treatment system was included. Big thing was that Fluid Cooling Systems is versed in Ford Motor Company and all the big manufacturers for that matter, and we meet their stringent specs. Most cannot, but we are versed in it and we're comfortable with it. Another MMR example takes place in the process world at ArcelorMittal. This application is for the cooling of induction furnaces. It's a dual loop design that involves stainless steel construction. The modular mechanical room houses an open loop pump station and supports open loop cooling towers. Open loop duplex pump stations is included. It has a Spyrex centrifugal separator for full flow filtration, and a 1,500-gallon tank is built inside. It has a chemical feed system. The stainless steel closed loop duplex pump station is all stainless steel construction and has 6-inch welded stainless steel piping. It utilizes plate and frame heat exchanger for isolation and a 1,000-gallon tank, and has a NEMA 12 control panel. Our MMR series enclosures are available in a myriad of colors and textures, as well as structured for higher wind loads and in stainless steel if that's something that you really need. All of the walls are interior foam and metal exterior. There are different thicknesses of the foam inside, and there are thicknesses of the metal available. Let's take a look at some applications that Fluid Cooling Systems has manufactured. This one has 4 air-cooled chillers here, and this is 2 banks of trim coolers that are set for a 60-degree set point, so that when the temperature hits 60 degrees, you'll start having some flow take place through these dry coolers, through these free coolers, to trim the load going to the chillers. There are 4 process PHE skids here, plate heat exchanger skids. That includes pumping, of course. There are primary and standby pumping and buffer and air separation tanks. This is on an elevated structure, obviously. This is a beautiful application and delivered some tremendous results to this process customer. In this critical duty application for a metals processing customer, we have 3 cell cooling towers, 3 PHE heat transfer skids here. You see the pumps and the valves and the controls. Duplex primary pump skid here with buffer tank, and duplex emergency pump with heaters, which is right here. This is a critical duty application. They built a concrete house for us. We installed the cooling towers up top, and everything else is inside the equipment room downstairs. A growth area that we have seen in our company has been in the world of data centers, both in traditional data centers using modular chiller plants with traditional and chill water and traditional approaches. The other thing is with ASIC servers for crypto miners. An ASIC server is basically a server with one function and one function only, and that is to make bitcoins or to make cryptos. The servers are mounted in large tanks. There's a high velocity of fluid that is flowed across the servers, and it is directed to directly and most effectively cool the processors. There are separate process and utility pumps across plate and frame heat exchangers as an option. That can also involve an engineered mixing valve with VSD process pump drives. And the reheat rejection can be to dry coolers with or without adiabatics. They typically do have VSD fans. Our successful work in the process world is extensive, diverse, and highly compelling. Our process cooling experience is designed and built by people familiar with industrial processes and cooling systems. Examples of our work include chemical heat transfer skids, lube oil systems, induction furnace system cooling, compressed air cooling, product coating systems including paint lines, die casting systems including acid cooling, hydraulic system cooling, quench bath cooling for metal processors, batch or continuous. We build heat recovery skids for any number of industrial fluids and processes. We build critical duty water systems and closed loop heat rejection. Here we see a modularized system with pumping, centrifugal separators here and here. We have plate heat exchangers here for heat recovery, chillers right here, and of course our pumps over here, buffer tanks and their separators. FCS is often called upon to develop highly customized process cooling systems with our customers. In this example here, we developed a system for cooling hot acid in a metal processing application. It involves stainless steel liquid paths, dry coolers, specialized pumps, controls. It's a very specialized application and a critical duty application, which is where we shine actually. This is a sample project at a well-known U.S. manufacturer where FCS designed and built a critical duty, fully redundant cooling, pumping, heat recovery, and rejection system. FCS is well known for meeting stringent specification and providing innovative engineered package solutions. The heat rejection systems we design into your project can take many directions. On the left, we see a large bank of redundant dry coolers for a power plant. On the right, we see a standard cooling tower system. And what I want to point out is that Fluid Cooling Systems builds the tower structures as well, including all the walkways and the catwalks. And we have a davit installed on this one to allow removal of parts much easier. Fluid Cooling Systems enjoys excellent relationships with the major cooling tower manufacturers. If your brand is something that you want on your site, then we have no problems in doing that. If you have no cooling tower in mind, then certainly we can purchase and install from any number of sources. On the left here, we see a BAC tower. On the right here is just a close-up of the walkway that we manufactured and an installed davit to allow maintenance to become much easier. We built a number of free cooling systems for HVAC duty. One is the cooling tower free cooling approach, where the system allows the cooling tower itself to provide the chill water by placing a plate and frame heat exchanger and some pumps and some controls in between. Another option is the condenser water heat recovery. The plate heat exchanger is piped in the hot chiller condenser water line to provide free pre-cooling for boilers used in processes or for HVAC reheat systems. Another approach is hot water production. Hot water systems use shell and tube or welded and semi-welded plate heat exchangers. Packages are compact and designed for the duty at hand. Heat from cogeneration and diesel generators are viable sources for hot water production using a free cooling heat transfer skid. Another use of heat exchangers is for pressure control. In high-rise buildings, heat transfer stations can be installed to reset the pressure in elevated applications. FCS can provide steam to hot water modules as depicted on the left, featuring shell and tube or semi-welded stainless steel plate exchangers, and of course duplex pumps and the controls for producing hot water. On the right we see a photograph of a 4-boiler system that includes the hydronic controls and the valves and the pumps. Fluid Cooling Systems is the inventor and the manufacturer for the Spyrex centrifugal separators. The Spyrex units were designed using computational fluid dynamics. There are no moving parts, and they're available from 1-inch pipe size to 20-inch pipe size. The Spyrex design is superior in many ways. They are available from 1-inch to 20-inch flanged pipe size, can accommodate flow rates to 6,700 gallons per minute. There are no moving parts, and they are known to preserve equipment life by keeping particulate out of the water stream. It has maximum particle removal and minimum pressure drop. It's a very cost-effective performance device. Fluid Cooling Systems builds integrated heat transfer solutions that involves pumping and many other things. Here we see an example of a duplex pumping system with a plate and frame heat exchanger, air separation valves, and controls. Here we see a rather simplified duplex pumping system for chill water and condenser water on one skid. Because of the diversity of the applications that we're involved with, our pumping systems can take many forms. We provide multiple pumps per station, up to 350 horsepower per pump, and up to 24-inch welded pipe size. We provide chill water, condenser water, and plant water systems. We provide variable speed drives or constant flow systems. We can provide piping in variable primary and primary secondary schemes. Integrated Spyrex centrifugal separators are fairly common on the condenser side. Filtration systems can include bag and sand types. Plate and frame heat exchangers with valves or manual operation can be provided. Buffer tanks, air separators, instrumentation, and hydronic specialties are always provided. Specialty pumps are available for industrial fluids. Specified materials of construction, including stainless steel and seamless piping, are available. We work with special temperatures and pressures because of the applications that we're involved with. And as I said, we can provide standard or seamless piping depending on the application. At Fluid Cooling Systems, we believe in online technology in order to scale, in order to make our reps more productive, and in order to allow the communication flow to just be more seamless. We have an online pump station configuration tool that we're releasing very soon. It includes multiple pumps, closed or open loop configuration, chilled or tower water configuration, optional expansion and buffer tanks, filtration, air, and dirt separation systems are optional, Spyrex centrifugal separator, chemical feed system, and controls. What's beautiful about this configuration tool is that it can never give a wrong answer because it's based on rules. The system provides the ability to correctly configure a pumping station, and it provides drop-down menus that are populated with choices that are valid for what you've already done. It then provides you a configuration that includes the piping loop design, type of water service, pumping configurations, expansion tank, buffer tank, air separation system, pipe size and material, filtration, the Spirix centrifugal separator, chemical feed system, and voltage, and of course a configured model number to easily decipher what it is that's been configured. Just as we have created a pumping configuration system, we have also created a modular mechanical room configuration system online. It allows you to use logical choices and drop-down menus to provide a correctly configured starting point for a modular chiller plant. It provides a generic quotation, a specification, and a submittal in minutes. At the end of the exercise, it provides a configured model number with the type of plant, the type of chillers, and brand, and we can utilize whatever brand is really required for the application and owner preferences, the type of architecture of the enclosure, the water flow design, the heat rejection type, cooling towers, dry coolers, etc., filtration and water treatment system, chill water pumps, quantity, type, condenser water pump, quantity and type, boiler and hot water systems, free cooling systems with and without valves to make it a fully automatic operation for winter operation, control systems, which can be PLC or DDC, space cooling and heating inside the mechanical room, the warranty type that's purchased, and the startup and commissioning, and of course the voltage. We see these configuration tools as an advantage in the marketplace because it gives our sales engineers a head start, conversation points with the consulting engineers to really drill down on the details and to understand the design assist process as it unfolds. These configuration tools facilitate that by providing documentation, document links to the manufacturer's components, and a place to start the conversation towards a final solution. We're very excited about our DDC control system that's coming online, hopefully later this year. It's the most advanced control system that I have ever seen when it comes to controlling the amount of energy in turbocore-based chillers using evaporative condensers. This particular application took place some years ago, and when was that? 2011, and it is in Chicago at a large data center. It features evaporative condensing, a very large surge tank with refrigerant optimization, and 500-ton turbocore chillers. I want to point out the run state. The chiller kilowatts in this particular state, and this was real time at the time, was drawing 0.0563 kilowatts per ton. That's on the chiller. Tower fan 041. The point is that the entire system, by using this refrigerant optimization and using an evaporative condenser in a turbocore oil-free chiller, was able to get the total system kilowatts down to what we show here is 0.165 kilowatts per ton across the chillers, tower, chill water pump, spray pump, and the pumper kilowatts. So this is just an amazing amount of technology that's taking place here, and we will have this available later this year. HEADS is an emerging technology that we're excited about. It has relevance to the packaged chiller plant because of the variable set points that HEAD wants to implement on the chillers and on the condenser fans and the chill water pumps. HEADS is the ability to use warmer water across specially designed coils and a large delta T to remove moisture out of the air and then use that reheated water to a reheat coil, again specially designed, to reheat the air and deliver lower temperature back to the chiller, which reduces the chiller load. It's an exciting piece of technology, been developed in California for many, many years and been vetted by the U.S. military for use in laboratories. For humidity control, we think it's the most energy efficient approach available. You really allow the air handler to do the control of the chiller plant when it's done correctly. So keep that in mind. Many of you know that I came from the world of Turbocore since its beginnings. Turbocore delivers oil-free, sustainable performance. They are variable speed centrifugal compressors, magnetic drives that achieve very, very low energy usage at part load. They are ultra low noise. The magnetic high-speed DC drive is virtually silent. All compressors are on one evaporator, which conserves energy. Optimized chiller plant controls are very mature now, across multiple chillers and multiple compressors on each evaporator. Chillers are being designed now for elevated chill water temperatures. This is especially relevant for the data center world. Modular mechanical rooms with evaporative condensers are available. And quite frankly, that's a secret sauce in my view. Would you marry an oil-free compressor at part load with evaporative condensing, you really do achieve the lowest total kilowatt usage. Chillers and plants with integrated free cooling are available. Refrigerant economizers with direct injection are available. There are low GWP refrigerants, including R1234ZE, available. Engineers have an unprecedented opportunity to provide critical cooling while realizing significant energy savings with sustainable operation. There is a very exciting convergence taking place, and fluid cooling systems will be right there with equipment to make it work. That being machine learning and AI. What's taking place is that sensors are being installed all through a facility and through the chiller plants, the chill water set points, the condenser, the tower, the outdoor temperatures, the air handling. Everything that's taking place is being fed to sensors and then fed to basically large servers that's being stored in very small increments. And then AI takes over and looks at all of the different settings, all of the results of those settings, and makes informed choices that get better and better over time. Google proved it. They allowed the machines to not override the human counterpart, but over time, the machine learning and AI overtook the human being's ability to dial in the ideal thermal equation for the data center. And now we see that machine learning and AI is going to be remarkably impactful in our world in coming years. Ricardo Schneider, the president of Danfoss Turbocore, noted the following, quote, "Data analytics will make smart hydronics the core technology of building efficiency." I think he's right on target with that. AI, machine learning, is going to be big. We call it AIOS, and we'll see it probably 2022. So we've looked at some products and certainly some solutions, and we've learned why packaging and modularization is so compelling in today's world of resource density, as Goldman Sachs referred to it. So let's look at fluid cooling systems. Who are we? We build in 2 locations. Our smaller location is in Flint, Michigan. This is where we build many of our pumping skids and some of our larger things. But when we build our larger equipment and need more space, we build it in the Lee facility, which is up the road. We utilize 2D and 3D AutoCAD and SolidWorks. We have manufacturing capabilities of small to large structures. We have our own structural engineering in-house, 2 PEs. We are AWS D1.1 certified in welders. We do MIG, TIG, and arc welding. Fully equipped welding and fabrication equipment is on site. We can work with carbon steel, stainless steel, and aluminum. We have full machining and sheet metal capabilities, high definition plasma cutting to 2.5 inches. We have Omax water jet cutting system, tube benders, 12-inch brakes and shears. From a manufacturing standpoint, we can build just about anything. We have a scalable business model. Our main production and large system manufacturing facility with skilled people and equipment is scalable. We utilize enterprise class online business functions, and we are equipped for growth. We go to market with sales engineers and enjoy sales engineers in most areas of North America in process and HVAC disciplines. People are key to the success of any business. At Fluid Cooling Systems, we have people with experience and vision. Bob, our founder and president, is a PE and a world of knowledge, especially in the process world. Darren Gary, PE also, came to us from a big competitor and understands the world of both HVAC and process. Jackson Ball, you've known me for many years, many of you, and I've been a chiller head, shall we say, for too many years, 27 years they say. So what makes our team compelling? Well, first of all, we listen and we collaborate with our customers. It's not about what we build, it's really about the solution that's required. Project success is assured with professional engineers designing to exact customer requirements. This is our goal every time. We have a leadership team with a history of success, and we are known for an ease of doing business. And in this business, in this world, that actually is a pretty fundamental thing that people enjoy. We have quality control from the shop floor to the final commissioning. We believe in quality just as our customers do. And we deliver solutions. It's much more than a tagline. It is really core to our culture. Success starts as a team, and there's a good team at Fluid Cooling Systems. So to recap, what makes Fluid Cooling Systems different? Our problem solving across diverse disciplines is certainly a factor. Process and HVAC, we are not limited by a narrow product scope or application scope. The competitive landscape favors our entry into the marketplace and position. The big guys, and we know who they are, they've set up their factories to compete with each other. But then along comes Fluid Cooling Systems, and we do many of the things they do and do it better and at a better price point. We think we're in a very good position from a market competitiveness standpoint. Fluid Cooling Systems provides precision PE engineering that yields reliable performance. We are known as design build champions. We get into the weeds with our customers and we come up with solutions that work and work well. Quality manufacturing culture, ISO 9001, we take it seriously, and it's handed off from person to person on the plant floor. The basis of design and specification leverage our strengths. Chasing after specs is harder to do when you're dealing with a level of modularization and the design assist work that goes into these projects. Fluid Cooling Systems is nimble and flexible. Diverse process and HVAC expertise that can be utilized. We have a very high build quality, perhaps the highest build quality and attention to detail that I have seen in our world. We can provide ruggedized, industrialized PLC or DDC control networks. We have standard and highly custom design. We are effective in diverse process and applied HVAC markets. We are known for ease of doing business. We have been told that so many times that we're just easy to do business with. We make complex things seem easy, and we do deliver solutions that work. Some customers that we do business with, repeat customers mind you, are GM, BP, Magna, ExxonMobil, Ford, and many, many others. You can look at our website and see much more about us. And thank you very much for being with us today. My name is Jackson Ball once again. That is my email address and my mobile phone number should you ever decide to reach me. And again, thank you very much for your time.